Welcome to ClickMyProject.com.
Let me discuss about the project Energy Efficient Spectrum Sensing for Cognitive Radio Enabled Remote State Estimation over Wireless Channels. Let me discuss about the abstract of the project. Energy efficient discovery and effective sharing of spectrum opportunities are the most challenging issues in a multi-channel cognitive radio network with multiple secondary users. Distributed opportunity spectrum access scheme based on sequential channel sensing in decentralized CRN. Different from the traditional spectrum accessing scheme, the scheme proposed allows a secondary users to sense many channels one by one sequentially in a slot. Opportunity spectrum access based on sequential channel sensing in decentralized CRN. Simulated annealing is a probabilistic technique for approximating the global optimum of a given function. Specifically, it is a meta-heuristic for approximate global optimization in a large search space. It is often used when the search space is discrete. The SES heuristic considers some neighboring states of the current states. The probabilistically decides between moving the system to states and staying in states. These probabilities ultimately lead the system to move to states of lower energy. This approach jointly addresses when to perform sensing, which channels to sense, in what order, and how long to scan each channel. Let me discuss about the flow diagram for our process. Initially, design physical space within sensor sampling period. It is based on the sensor state in dynamic system, and also generated the cyberspace model, which are based on the sensor sampling period. And for the channel under consideration, its bandwidth W is equal to 2 MHz and a noise power on 1 milliwatt. The signal to noise ratio of the channel received by the sensor during the channel's busy period is -3 dB. Here adapted the Poisson channel model as described, with the average channel busy and ideal rates alpha is equal to 5 and beta is equal to 30 respectively. The sensing parameter epsilon d is equal to 1.2. The maximum sensing time is tau is equal to 250 units, with the unit channel sensing time as 0.1 milliseconds. In a multi-channel scenario, the sensor data can be transmitted to the remote estimator via one of the orthogonal channels. The average busy and ideal rates for channel are determined. All the other parameters of these channels are set the same as those in the single channel scenario. To run the proposed OSSA algorithm before transmitting the packet, the sensor must check the channel state and transmit packet only when the channel is in its ideal state. Perform process with a single channel and a multi-channel. A Lagrange multiplier is applied to the first constraint to transform for dual function. Propose a simulated annealing based optimal spectrum sensing algorithm to randomly search the sensing time. To deduct energy by each channel each iteration by only randomly generating a sensing time. Evaluate the objective Lagrange function each iteration of OSSA. Analyzes the computation complexity. The estimator runs the algorithm and finds the solution offline. It sends the solution to the sensor, which operates according to the solution from them. If we discuss about the running procedure for our process, select the main.mfile in the current folder, right-click the file and run for executing this process. Here we obtain the results and with respect to graphical representation. And this is the system state which have been calculated using physical space model. This is the cyberspace model. System noise has been calculated. This is the covariance of the prediction result, and this is the sensing time on each channel for varies of iteration, and this is the estimation performance over time. Here the mean error covariance has been calculated, and this is the sensing time under OSSA model. Here the 3 channels are performed, and we obtained the sensing time for 3 channels for various SNR values. And this is the sensing time under OSSA. Consider the 4 model, and here the 3 channel times are obtained, and this is the sensing time under OSSA 5. Here the sensing time for 3 channels are obtained, and this is the performance comparison for all OSSA and OSSA 4 and OSSA 5 approach, and here the performance comparison for various approaches has been calculated, and this is the performance comparison for OSSA, OSSA 4 and OSSA 5, and also the iteration level for has been calculated for various SNR value, and this is the sensing time for 6 channel. Here they considering 6 channel, and the sensing time will be raised for every m value will be increased. Finally, energy efficient spectrum sensing problem for remote estimator has been estimated, and it works out performed with the existing method. Thank you.